Simulink, developed by MathWorks, is a commercial tool for modeling, simulating, and analyzing multi-domain dynamic systems. Its primary interface is a graphical block diagramming tool and a customizable set of block libraries. It offers tight integration with the rest of the MATLAB environment and can either drive MATLAB or be scripted from it. Simulink is widely used in control theory and digital signal processing for multi-domain simulation and model-based design. The toolbar of the Simulink library browser offers the following features, from left to right. Create a new model. Opens a new empty worksheet where a Simulink model can be constructed. Open a model. Opens a dialog box where you can specify an existing model to be opened. Stay on top. Forces the library browser window to always stay on top on your desktop. Find a block in the library browser. When you specify a block name in the entry field next to the icon, clicking the icon will bring you to the location of this block. The Simulink library is divided into several categories. On top we always have the Simulink 3 standard library containing most of the standard blocks. The categories listed below the Simulink library depend on the locally installed features. Important for control theory is of course Control System Toolbox. A library category can be expanded by clicking the plus sign, which will then show the underlying hierarchy. At the lowest level you find the blocks that can be dragged to your worksheet. When you select a block, left mouse click in the library browser. You can read a short description and view its appearance in your worksheet at the bottom of the library browser window.
This is Marco Wu from eProgrammer.com. I'm going to talk about how can we build a high-pass filter in Simulink. The only thing we need to do is put this equation into the transfer function of Simulink, and then that is the high-pass filter. When we put the coefficient, that is the numerator coefficient, you can see I put 100 Hertz. That is 100 Hertz high-pass filter. Okay, so that is 1 over 2 pi times 100 times s divided by 1 over 2 pi times 100 plus 1. And I have the signal input and signal output. The signal output, I use a scope to monitor it. I put a 1 Hertz signal into the transfer function, and you can see the amplitude drop from 1 to 0.01. Now, I change the frequency to a very high frequency. Let's see the amplitude. What will be happen in the amplitude? Okay, auto scale. You can see the amplitude is close to 1. That means the high-pass filter allows this kind of high-frequency signal to pass it through. So basically, to create a high-pass filter is very simple. You only need to copy the equation that in my Simulink block to your Simulink.
1, 2, 3. There's something on your phone. There's wasn't the one who planted me here. I'm just a sunflower, but we need power and entire infantry. You like the taste of brains, we don't like zombies.
I used to play football. Well, don't protect my head. I have a screen door shield. We are the Undead.
There's a zombie on your lawn. There's a zombie on your lawn. We don't want zombies on our lawn. Maybe it's time to reevaluate. I know you have a lot of food on your plate. Brains are quite rich in cholesterol. You're dead, so it doesn't matter. Instead, we'll use the solar power to make a lawn defense at any hour.
I like your tricycle. There's powder on my head. I'm gonna eat your brain. We are the Undead.